So here we go. I'm Jesse McDougall. I am a farmer at Studio Hill, a farm down in Shaftsbury, Vermont. We are a fourth, fifth generation farm, fifth being that little guy right there and his little sister. Their great grandparents purchased this place in 1936, and they were looking for food security. They were coming out of New York City after the Great Depression and looking for food security, and decided that land was the only way they could ensure that they could feed themselves and their community going forward. And so we've been here trying to live up to that mission ever since. I am an accredited professional with the Savory Institute, a holistic management accredited professional. I'm also the co-founder of Regenerative Food Network, which I'll talk to you a little bit more about at the end of this presentation. And I just want to make the point that all photos that you see in this presentation are from our farm, and that's not just because they're pretty. I just wanted to make the point that we've made all the mistakes too. So all the do's and the don'ts are from us. And that we came here through a long period and long trial and error, and learning from a lot of people who came before us. So before we get into why, let's talk about what I mean by regenerative agriculture. Well, it's a hot topic, and the definition of it is wide, big, and vague often. So I'm going to dial it in for you today in terms of what I'm talking about. The way I see agriculture today, I see that the way I think of it is there are only two types of agriculture. There is regenerative agriculture and degenerative agriculture. Regenerative agriculture I'm defining as any system that regenerates natural cycles and natural resources in the land where it's practiced. And conversely, degenerative ag is any ag system that degrades natural cycles and depletes or degrades natural resources in the land and the surrounding ecosystem. So by that definition, any standard convention or product, agricultural convention or product, falls into one of these two categories, whether it's industrial, conventional, organic, permaculture, agroforestry, livestock, vegetables, what have you. And I know that there's a lot of emotion embedded in some of these terms, and a lot of my team versus the other team kind of investment, but all of them can be done regeneratively, and all of them can be done degeneratively to varying degrees. Maybe with some exceptions in there. Some are generally regenerative and some are generally degenerative. But my point is that depending on when, where, who is practicing using these tools and practices, they could be very beneficial for the environment. And if they're done in a completely different context, they could be hugely degenerative. And so, for example, our farm is on top of on wet rolling hills, and if we were to practice, low till or low till vegetable production, over time, our topsoil would slide down the mountain. But if we were to practice low till vegetable production in the valley using the same tools, same system, same farmer, on the river bottom floor, then we could do it regeneratively for years. And so one of the things that frustrates me in this conversation today is the concept that one product or one practice is regenerative and one is not. It's all contextual. It all depends on how and where you're farming and the climate in which you're doing it and the soil type and the grade and So when I talk about regenerative ag, what I'm talking about is regenerative management. What I see as regenerative is the management of the land and the decision-making process. So just as an aside, the whole meat versus vegetables argument I see as a false flag. Industrial meat, is terrible for the planet, and industrial vegetables are bad for the planet. And industrial meat is worse for the planet because it's based on corn, which are industrial vegetables, right? So it's a double whammy. But livestock, holistically managed in the right context, they're great for the planet. And annual vegetable production done regeneratively is great for the planet. So if you're basing your food decisions on environmental concerns, the argument shouldn't be meat or vegetables, because that's just, the destruction of the earth quickly or the destruction of the earth less quickly if you're choosing industrial food. It should be the litmus test should be regenerative or degenerative. And at the moment, the only way to know is to know the farmer and to shop locally and to know and to see, often to go to the farm and see the results on the land. And there are certification programs, new ones starting and great ones coming. And so we'll have more data down the road, but these things are still in development. Another thing I want to point out, regenerative ag is, it's an outcome-based designation, right? So it's tool and practice agnostic. But let's take a step even further back to 105,000 years ago. I've marked right here on this map the Fertile Crescent, what is widely known as the birthplace of agriculture, and by that I mean the cultivation of crops for human consumption. Obviously, well, maybe not obviously, but agriculture sprung up around the planet at different times and in different systems. But what I want to draw your attention to is the Fertile Crescent, the area of land surrounding the Euphrates and Nile River, is now the center of the desert, the expanding desert. And the question is why? I don't believe it's a coincidence. I don't believe it's a fluke of a changing climate. This is where humans started tilling and working the soil to produce a lot of annual crops and specifically wheat and barley, peas, lentils, vetch, peas, flax, that sort of staple crops, which allowed their society to flourish, of course, but was detrimental to the land. And it is now well known through, human learning that overworking the soil, whether it's here in the Fertile Crescent or whether it's in the Dust Bowl in the 1930s, leads to desertification. And so from this point, agriculture spread, and from this point, the deserts grew. And you can see now that in other places around the world that are starting to dry out, a lot of them have as a common denominator industrial ag practices. When we were a new species and tilling the ground, we could get away with it. The impact we had was small, spread out, but we are now doing tillage, and even worse, spraying pesticides and herbicides and whatnot on so much land so efficiently that we're suffering the ravages of the unintended consequences, right? The climate change, the biological collapse, the species extinctions, water pollution, and so on and so on. If I could point to one process that is the most destructive of them all, I would argue that it is tillage. Tillage is the mechanical process that converts what should be a carbon sequestering, water sequestering ecosystem into one that emits carbon and sheds water. So this is a picture of our farm. We're tilling here. This was in 2013, and it was the last time that we did it. But you can see the grass coming up through the cornfield. The grass is growing. As it grows, it pulls the carbon out of the atmosphere. That's what photosynthesis does. It pulls the CO2 in, breaks that O2 off, releasing it as waste, thank goodness, and uses that carbon molecule to bond with the H2O coming out of the ground. And it uses, what it does is it takes that hydrogen molecule and creates carbohydrates. Carbohydrates in the form of leaf and twig and root and sugars. Complex and simple carbohydrates. Now, what happens to that blade of grass or that tree or that twig determines what happens to the carbon that was pulled out of the atmosphere as the plant was growing. So if the, let's say if the plant falls over in the woods and is then covered by leaves and whatnot, then the bugs come up from the soil in the forest and eat the rotting log and pull that carbon and those carbohydrates down into the soil, right, where they are safely stored for hundreds, if not thousands, if not millions of years. That is that's the same story in a Vermont hayfield. If the grass is eaten by animals, for example, roaming packs of herbivores or the deer moving through the area, converted to manure, trampled down, then the bugs come up and eat that and pull it down where it's safely sequestered. Until you come through with a tilling machine. And what you do when you mechanically turn over the soil is you expose all that carbon in the form of carbohydrates, of organic matter, up to the elements, the wind, the rain, the sun. And what happens is that punishment from the elements breaks apart the carbon from the hydrogen chain. It bonds with the O2 in the atmosphere and floats back up into the atmosphere as CO2. So that field that should have been pulling carbon into the earth is then spewing it back up into the air. That's oxidation versus biological digestion. So what we are trying to create, and what people have been trying to create for, let's say 100 years in the organic / regenerative ag movement, and what indigenous peoples have been doing around the planet where tillage wasn't part of their agricultural system, is trying to create an agriculture that strengthens and amplifies these four natural cycles in ecosystem. That's the mineral cycle, the water cycle, biodiversity, and the energy flow. If agriculture can produce crops, food, fuel, and fiber while strengthening these systems, then humans, and that becomes the default human behavior instead of relying on destructive technological tools, then I think humans will have made the next step in human evolution. In that we will have achieved the level of the sheep and the turkeys and the other species on the planet that have figured out, or I should say have evolved to a point where by expressing their natural behaviors, they make the environment more able to sustain them, feed them, shelter them, and by the way, everything else that's in that environment. So for example, on our farm, we have a flock of sheep, and it is our goal with that flock of sheep to allow them to act like sheep. And in fact, in some cases, we have to encourage them to act like sheep because of differences in the landscape, meaning that the predators are gone, the predators that move the sheep around in this valley for, hundreds of thousands of years, or however long sheep were here. I don't know that they're indigenous to the continent, but the wolves are, but they're gone now. And so the natural behavior of the sheep, which would be to bunch together in a pack and for protection and safety, dash out into a grassy field, eat all they can, trample everything in so doing, fertilize everything, and then dash back to the safety of the woods where they can then regurgitate and chew their cud, their ruminants, so they dash out into a field, grab, gulp, and go back to safety to chew their food. That isn't happening anymore. I mean, if you think about a cow or a sheep standing in a Vermont hayfield, the image that probably comes in your mind is a cow standing there chewing its cud, relaxed and not panicked for its life, running in and out. And so what the infrequent but intense trampling and grazing activity of these animals is what the grass evolved with for millions of years, and it evolved to thrive under that management, right? So any grass that didn't get stronger, any plant that didn't get stronger under the bunch, munch, and move management system got weaker and weaker over time, and anything that thrived in that management system got stronger and stronger over time. So what we have now is a planet covered in grasses that get stronger when they are infrequently but intensively grazed, trampled, and left alone to recover. And almost no grass on the planet and in no grasslands is that happening anymore, right? Largely because we have eliminated most of the predatorial threat around the planet, but also because we've put up houses and highways and, modernity. So if we want our grasses to express their full abundant natures, we need to recreate the systems under which they evolved to thrive and under which the sheep evolved to thrive. So it is a symbiotic link that we need to recreate to restore the natural abundance of our farm and of our world and of our grasslands, which cover 2/3 of the land, 2/3 of the terrestrial land on the planet. But the same is true in our forests, right? So if you walk out into the woods right now and you go to the spot you deem as the most pristine, the most untouched, the most abundant natural spot you can find, that feels like natural abundance to us. But 100, 200, 400 years ago, there were orders of magnitude more animals in the woods, more diversity of plants in the woods, more, everything right down to fungal networks in the woods. But we have changed and altered it so much that degradation is obvious in a sprayed cornfield, but where it's not so obvious is in the woods, where we have some deer and some turkeys, but not nearly the number we used to, and not nearly the number the trees evolved with, or the animals evolved with. So both are degrading. And in all these environments across the whole region, we need to focus on restarting these four ecological processes, right? So I'll just briefly go through them one by one. So the mineral cycle, and part of that is the carbon cycle, which is talked about often. The mineral cycle is the process of decay. When let's say, we'll just take manure, for example, because it's often vilified, and I want you to understand that it's not the manure that's the problem, it's the management of the manure that's the problem. But let's say our flock has a guard donkey named Ben, right? Ben travels with the flock. He thinks he's a sheep. He's an Instagram star. But he leaves these, and it's interesting, he came from a petting zoo and he was trained to poop in the corner of the pen so that the guy cleaning up after him didn't have to walk all around. So now he does that, right? In our paddocks, which are a quarter acre in size, he leaves this pile of manure in the corner, which is, because we don't pick it up and because the point of our system is to spread the manure out, it's kind of funny but frustrating. Anyway, that pile of manure, were it to fall on a dead patch of ground or gravel, it would lay there in the sun, in the wind, in the rain, and the nutrients would leach and into the soil and not be absorbed by anything. The carbon in that manure pile would be broken off by the elements, as I described earlier, and become CO2 again, and it would be ecologically unbeneficial and not damaging in some cases. And that's what's happening on the industrial level. You scrape out these dairy cow barns and you pile up that manure into a pit or lagoon. Too often, that manure leaches out in cracks or whatever, or it's spread back onto soil ecosystems that are dead. And all those nutrients in such a high concentration are an ecological disaster. But if Ben's manure falls onto, as they are doing now, onto a live, healthy, and active soil microbiology, what happens is the bugs come up out of the soil, and in 2-3 days, it's been pulled down into the earth. You can flip that patty over and see the bugs teeming through it, pulling everything down into the earth. As the bugs pull that manure down to the earth, they eat it. Their waste is a more refined form of carbon. Then after the bugs, the algae, and then after the algae, the fungus, or, it just works its way down through the soil food web until it becomes a form of acid called carbonic acid. And that acid breaks down the sand and the rock in the soil and releases those nutrients and those minerals into the soil as plant available form, that the roots can then take up into the plant, making it stronger and healthier. And not the macronutrients, the nitrogen, phosphorus, and potassium, but all the micronutrients as well. Copper, molybdenum, manganese, all of the hundreds of micronutrients that the plant needs to be A, healthy, B, tasty. It's why an apple today keeps the doctor away is no longer true. We're growing so much of our food in soil where the mineral cycle is non-existent. So what the plants take up is what is spread down on the field as pellets. So we're getting food that is full of nitrogen, phosphorus, and potassium, and nothing else. So you'd have to eat 25 apples today to equal the nutritional content of one apple grown in 1950. So we watch the mineral cycle by seeing how long it takes that manure pile or that rotting leaf to decay in the soil. And if that decay is happening, we know that it's being carried down through the cycle and that the plants have plenty of available minerals and nutrients to be strong and healthy. And that is a positive feedback loop, right? So the healthier the plants, the healthier the animals, the more abundant the grass, the more animals, and so on and so forth right around. Now, on the tail end of that, I should say following the mineral cycle, because of all the carbon involved in the mineral cycle, is the water cycle. If the water cycle if there's a lot of carbon and organic matter in the soil, the water can infiltrate the soil, and for every 1% increase in organic matter in 1 acre of soil, it can hold 20,000 gallons more water, so that when an area experiences a drought, such as our area now in southern Vermont, the field can keep producing, or the garden or crop can keep producing right through it, because there's plenty of water safely stored down below. And when you till the ground, obviously, you expose that to the hot sun, and a lot of that water evaporates out. Biodiversity is key, because once you get the carbon down in the soil and the bugs come back in the soil, the birds and the worms and the whole soil above, the whole food web above the soil comes roaring back. When we started our journey here, you could walk through one of our fields and not see a cricket or a worm or a spider or a butterfly. There was no life in our field because there was no food there for the critters. There was no carbon in the soil for them to eat, no rotting anything. So I like to say, if the water cycle is how everything drinks, the carbon cycle is how everything eats. But once we got the carbon loaded up with, the soil loaded up with carbon again, everything started coming back right up the whole ecosystem, to the point where we're now seeing timber rattlers on the farm, which is an endangered species. And that's one of the proudest achievements of my life. The fourth thing we watch for is energy flow. Is the sun able to, well, let me think. Is the sun being maximized in its capture? So when the sun is falling from the sky, does it travel through many layers of canopy, whether that's grass canopy or tree cover canopy, on leaf, on leaf, on leaf, on leaf, on leaf, until the soil is fully shaded? Are we maximizing the amount that we're pulling out of the sunlight? And then once we do, where does that go? So now the question is, oh, that's a squiggly. I don't know why that's there. So I'm going to focus now on the 4 benefits of regenerative agriculture that I see. And I'm going to focus on how regenerative agriculture affects these things, and the why should make itself pretty clear. Climate change, the big boogeyman in the sky. Climate change is I think a terrible term for what's happening, because it's vague, because the climate has always been changing with ice ages and whatnot. So it gives our doubting opponents some fuel to go on. But more specifically, you can't beat the boogie monster, because you never know how he's going to come at you, right? So if we can't name the problem, we can't solve the problem. So I like to talk about climate change, and this is something I learned from Gabe Brown, a farmer in North Dakota, about a broken carbon cycle. Now, if you look at these 2 pictures, these are both on our farm. One is a field that was in corn, and the same field holistically grazed by our flock of sheep and Ben. And our mantra on the farm now is carbon down, carbon down, carbon down. To make it, we brought the animals in to restart the carbon cycle, because we have wet rolling hills. Bringing animals and livestock in, and specifically sheep, not cows, because of our wet rolling hills. We could have done it with, no-till vegetable crops or perennial crops, a fruit orchard. There are a lot of ways to restart the carbon cycle, and we chose one that worked for our context. But there are a lot of ways to do this. But once you're able to do it, that carbon, instead of the grass just dying standing or getting bush hogged every year and dying on the field or oxidizing on the field as grass clippings, once you're able to restart this cycle of carbon being drawn down into the earth, the water, as I said earlier, is drawn down into the earth and held there. And that water coming out of the atmosphere, that water vapor coming out of the atmosphere, is the single most effective thing we can do to cool the planet. The water vapor is having a much higher greenhouse gas effect than carbon and methane and all the other greenhouse gases up there. We could cool the planet relatively quickly. I was talking with Walter Yenna, who is an expert on this down at Australia. He says we could cool the planet in 20, 30 years. And that was actually backed up by a study the UN climate scientists released last year, saying we could solve global warming specifically in 30 years with $30 billion. And I encourage you all to go look for that study. using these regenerative land management techniques. If you think about it, there are only 3 places on the planet where we can store carbon. That's a very humanistic centric way to phrase that, but let me say there are only 3 places on the planet where carbon can exist. It's in the atmosphere as carbon dioxide, in the oceans as carbonic acid or animal and plant life, and it is in the soil as organic matter. So 2 of those carbon sinks are maxed out, right? We have too much CO2 up in the atmosphere, which is global warming and climate change, and we have too much in the oceans, which is the acidification of the oceans. And the soil across much of the Earth's surface is depleted in organic matter. So the only solution and the quickest solution I see to climate change is to get that carbon down into the soil using regenerative land management in ways that restart the carbon cycle. And considering that 2/3 of the world's land mass is grasslands that can't support row cropping because it's too dry, or trees because it's too dry, yet could in the future, I think a good place to start is with holistic livestock management, where the only way water moves and the only way nutrients move often is through the rumen of the animals and manure and urine of the animals. Obviously, it must be done well and must be done holistically, but we've come to an odd place in our human thinking where we believe poison is good to spray on our food and animals are bad for the planet. Obviously, that's not true. Bad management is bad for the planet. So human health, as I was saying before, an apple a day keeps the doctor away is no longer true, right? Because of the way we're managing our soils. So, one of the most interesting things I've heard and read recently, I'm looking into, or I'm studying, I should say, is the feeling of hunger in your body is not your body asking for calories, it's asking for nutrition, which makes a lot of sense to me as somebody who used to eat constantly from the drive-through, giant sacks of nutritionally deficient, if not void, food, and still feel hungry, even though I'm bloated and sick, still feel hungry on the other side of it. Whereas if I eat from my garden now, I'm sated pretty quickly without the giant bloated waistband. And one of the that can give you a clue into the obesity epidemic right now, where people can eat and eat and eat and eat, including myself, and not feel sated at the end of it, because our food, the food we're cranking out into the system, is nutritionally deficient. And one of the reasons that's happening is our overuse of pelleted fertilizer. There's a symbiotic process going on between the plants and the soil microbiology. So I'm in Vermont, so I'll talk about the maple tree. All right, the sacred maple tree, everybody knows, puts this sugary sap down, up and down through the tree, right, in the spring and after the winter. So what it is doing, it's taking a lot of that carbon out of the atmosphere and water out of the soil, and producing these very sugary sap that it pumps down into the soil. And what it's trying to do is draw critters' soil microbiology to its root zone, where it is feeding them this sugar water. In exchange for that outpouring of food, the soil food web eats and wastes and produces that carbonic acid, which releases the nutrients and minerals back to the maple tree so it can wake up strong and healthy, getting all the micronutrients it needs to be a strong and healthy tree. When we put down NPK pellets, nitrogen, phosphorus, potassium pellets, those are the 3 macronutrients a plant needs to look like a plant, and a tomato needs to look like a tomato and whatnot. But in the case of the maple tree, if you put down NPK pellets around the base of the maple tree in the spring, it would pull those up into its plant root zone, and as an energy saving measure, it would say, oh, I don't need to put down the sugar water because I have all the things that I need, and I can devote more energy of these carbohydrates into leaf, root, and stem, right? So it doesn't, the NPK pellets effectively starve the soil microbiology of their nutrition coming down from the plants. So we are short-circuiting that symbiotic relationship. So when we fertilize our food across all industrial agriculture, what we're doing is starving the soil microbiology and short-circuiting that symbiotic relationship, creating nutritionally deficient food, which is leading to, of course, so many of the chronic diseases we're seeing today. I forget the exact percentage, but something like 6% of American children in 1950 had a chronic illness, and now something like north of 50%. I don't know the exact number, but look up the statistic. North of 50% have a chronic illness due to dietary inefficiencies. And one of the biggest problems is we can go to the grocery store and buy broccoli and buy apples and buy healthy, well, I should say vegetables, fruits and vegetables, and things we perceive to be nutrient dense. But if they were grown in dead soils, they don't do much for us. And if they were picked more than 7 days before you eat them, they are essentially nutritionally dead anyway, because of the loss of nutrition as it ages. And it can be actually more beneficial to you to eat frozen vegetables that have been picked and packed that day. They have more in them. Biodiversity. Oh, you know what? That was my 3-year-old daughter drawing on that. Okay, anyway, I figured that out. Here's the biodiversity issue. So look left, look right. This is the same field, right? So if there are no cycles functioning in the land, there's no carbon cycle, mineral cycle, I should say, water cycle, there will be no biodiversity, because there's nothing in that field for anything to eat. And that was, this is our hay field, and it's devoid of life. And yet when we bring in the sheep, and when we bring in the chickens, and when we bring in life again, what happens is the microbiome of the sheep and the gut bacteria of the sheep fall to soil, inoculate the soil with their bacteria and their life, which starts, if the soil is ready for it and can protect those delicate forms of life, they can breed and spawn and grow and create a healthy soil biology. That way everything can start spinning up. In our time here, we have, as I said, seen the worms come back, the birds come back, the turkeys, the grouse, the foxes, the coyotes, the endangered species come back. And as everything starts coming back, it's a positive feedback loop. The more life there is on this farm, the more resilience there is on this farm. So if you take a cornfield, for example, that's been, GMO corn, GMO Roundup and all that, if a blight comes through and kills corn, your crop is lost. Not only that, the whole ecosystem is then dead. Whereas in my hayfield, there are millions of forms of life, and if a blight comes through and sweeps out all the clover, there's still an abundant ecosystem there, and it can adapt and change and recover. Biodiversity is resilience. It is abundance. It is balance. It is the driver of all of these systems, of all of these cycles. And finally, and one that is near and dear to my heart, is the rural economic development aspect of regenerative ag. All right, if the wealth of a rural area is its ability to produce food, fuel, and fiber, or crops from the land, then what we're doing in the degenerative ag model is making ourselves poorer and poorer and poorer, which should be plain to anybody who's driving around with their eyes open. You know, silos are falling over, barns are falling in. We have, drug problems coming into the area, job loss, labor problems. This is all connected. This is all connected back to how we manage our environment. The degenerative ag model gets more and more and more expensive every year, because every time you spread pelletized fertilizer or spray herbicides and pesticides, the next year, not only do the prices for these things come up, because that's, the market, but also your field is a little bit less able to produce again. So you need more fertilizer, and you need more pesticides because of the weakness that you've created in your system, making it vulnerable to incoming pests. And the more herbicide you need to spray, because you're getting quote unquote invasive species into your field because you've opened the door for them. Just as a quick aside, if you're managing a hayfield, or I should say a cornfield, to keep it open, to keep it easy to mechanically manage, then what you're doing is you're opening the door for all the species, the first succession of plants that blow in by seed, whose role it is in nature to colonize a dead ecosystem. So they will blow in. And if you are trying to grow grass but are managing it so that it creates an environment for dandelions, then you're going to get dandelions. Whereas if you are giving the grass the treatment it evolved to thrive under, you're going to get stronger grass and no dandelions. And people ask us how we manage our weeds, and I say we don't. We manage our grass. But this degenerative economic model, where we are spending a lot of our dollars with companies, big companies, that then put it on a truck and send it out of town, the oil companies and the farming giant corporations, then our area gets weaker and weaker and more dependent on subsidies and giant funds out of town and corporations, and we lose our independence and we lose our sovereignty. We can reverse that, of course. When we made the decision to stop spraying fertilizers and pesticides and everything, which we were moved to by a death in the family and the fear that they were linked, that the cancer was linked to the chemicals, we put down that bill and we stopped paying those for all of the chemicals and everything. And that was a huge economic burden lifted from us. And I've told this story many times, but we lost crops for a number of years and experienced a lot of nail biting and panic, but came across the idea of regenerative ag and positive feedback loops and building nature back to its natural abundance. But we were able to use the money that we saved on chemical farming to hire a local employee to come up and help us move animals every day. And the animals, the sheep and the chickens and the turkeys and the bees and the pigs, due to our holistic management practices, did the work that the chemicals did the work that the fertilizers did. in managing the ecosystem and fertilizing everything, but they did it better. They did it with lasting effect, and they did it as a revenue stream. So huge swing economically, huge swing ecologically. And now the hay fields where we just used to produce hay are now producing lamb, chicken, turkey, sheepskins, eggs. So the calorie and all the hay that we used to produce. So the calories per acre are through the roof, dollars per acre are through the roof, and we're getting stronger and stronger and stronger every year, and more independent every year. And this is not a trick. This is not something we could do on our farm, but other farms in the area can't figure out. It's just a change in management. So were we able to recreate this system throughout our region, not just Vermont, but the Northeast, we could rebuild our rural economies so that we were exporting healthy, high demand, actually nutrient dense food to larger markets and bringing dollars home where we can create good jobs on the land and make our land ownership profitable again, which is key so that we're not vulnerable to outside development. And if you take the large picture of it, the degenerative ag model makes a few people very wealthy in the cities, and this regenerative ag model reverses that consolidation of wealth and power and puts both of those back in the hands of the people. The only input on our farm is the carbon that is flowing across it freely and abundantly. And we just have to figure out the system every day of how to capture it through our green and growing plants and how to keep it here. And we use animals to do that, but there are a lot of different ways to do that, to leave it in the soil, making our farm more and more and more abundant every year. So to that end, it's talking about the big regional approach. I mentioned at the beginning the Regenerative Food Network, and this is a collaborative effort, a company that was started by your very own president, Bill LeBerge of Grassroots Solar, and our farm, Studio Hill Farm, and a company we've partnered with called Embata Capital to create the Regenerative Food Network, which will work with all farmers. Just because we're named the Regenerative Food Network doesn't mean we're only working with regenerative farms, but we want to help all farmers of all stripes and all products, because all farms are struggling, all farms need help, all farms are at risk. But our goal is to build the vehicle that helps farms transition from whatever practice they're doing now, whatever degenerative practice they're doing now, to whatever regenerative management helps them find abundance in the future, given their context, their landscape, what they want to produce, what their family wants to do. We are also building a renewable energy network across the region for a number of reasons. One, it's the right thing to do. Two, we want to help farmers get more out of their land, whether that's solar panels on a barn like we did here in this photo, or solar panel in the field where you can graze animals under it or grow crops in it. We're not looking to replace prime ag land or any ag land, but we want to amplify it. So there are ways that you can position the panels so that you're not taking land out of production, and in fact you're in many ways amplifying it through smart management. And then we want to help the area get to 100% electrical power in our ag systems anyway. We're building a fleet of electric distribution trucks. We're looking at tractors and farm machinery to try to get diesel out of farming and keep our dollars local, so that the energy you're buying is coming from local farms and farmers instead of going to, Exxon and Mobil and whatnot. So That's the regional view. And if anybody wants any more info on that, please reach out. That slide shouldn't be in there. Where are we at? There we go. Thank you so much, everybody. Reach out at any of these places. You can call or text that number. You can email me there anytime. And we now have 10 minutes for questions. And if you have any questions for me, I'd be honored and happy to answer them. And I will turn to the chat. All right, first question I have is, does regenerative farming reduce the yield from an acre versus conventional farming? From Mike B. Very good question. The answer is no, it doesn't reduce the yield at all. If we're talking about one crop to crop yield, so we are now outproducing what we ever did hay-wise, grass-wise, with conventional ag, and we're doing it through drought, and we're doing it through floods. Because our fields are more resilient and more productive, because we've been able to restart and strengthen the natural processes in the land, what we're seeing is grass do things that we didn't see, we didn't think grass could do. And it's been really inspirational to see that. But if we're talking about production per acre, like I said earlier, we're doing that hay, we're doing more hay, but we're also doing on that same acre where we're producing hay, lamb, chicken, turkey, sheepskins, and all these other things. So our production per acre, calories per acre, dollars per acre is way up. And it took a few years. I'm not saying it's an overnight success. We started this in 2012 and we're now in 2020. So we started seeing our production outstrip what we did with chemical ag. In some fields, it took 5 years. And that it was a difficult hurdle to get over, to have that crop reduction over those years. And one of the things that our RFN, Regenerative Food Network, is hoping to do is help farmers over that hurdle. So Bill LeBerge, the mighty, asks, can you talk about ways you measure success? I can. Well, there are a couple ways that I think about it. One, at the highest level, I think about it in terms of how many butterflies are in the field. That's like the macro level. And I don't mean specifically butterflies, but if nature is flooding back to my farm, whether it's wild turkeys or bobolinks or monarch butterflies, I am measuring my success based on how much wildlife with free will is choosing to be here on this land. And if that's increasing every year, then I have a general sense that I'm doing things right and well. The other way I measure success is, if you want to put it into harder numbers, is we participate in Savory Institute's Ecological Outcome Verification Program. That is a program where our land is assessed every year in a matrix, which calculates, or I should say, assesses everything from how much bare ground you have on your land to water infiltration times to how quickly the how quickly the carbon is rotting down on your field. It is a measurement of the 4 ecosystem processes and how well they're doing year over year. And that whole system produces what they call an ecological health index number. And that is a useful number to know, just are you getting better over year? But also it gives you some insight into what functions of the ecosystem are thriving. Like your water is penetrating really quickly, but your mineral cycle isn't doing so well. And it helps you understand what changes you need to make in management to bring things back. The third metric of success really is, how are we doing economically? Nobody's going to save the world if they can't feed their family. If this farming endeavor that I love and do every day and want to do the rest of my life brings me to a point where I can't feed my kids, then I'm going to go work at Starbucks. I'll go work at McDonald's. I'll I will be the first in line to work for the Borg if, my kids look at me hungry. And that's just, I'm a softie. So can this land be profitable and not $5 a year? Can it create a thriving salary where I'm not just scraping by and being stressed all the time, but can it create something that makes me feel safe? And do I have savings? And I've scraped, we've panicked. I'm not looking, that's not the goal here. Farmers deserve better than that. And I guess the final measure of success is, do I want to get up and do it every day? And because this is direct action a person can take to fight all of these problems we face, then yeah, I want to get up and do it every day. And I'm blessed, and I feel honored to be able to do that work. So does my wife, Callie. Okay. How do I know if my food is grown by a farm using regenerative practices? Very good question. And the answer is, you go to the farm and you talk to the farmer, and you go back next year, you go back the year after that. You ask them about their philosophies, you talk to them. You have to know where your food comes from. The Savory EOV program is great. The Rodale Organic Certification program is great. These are things that we should use in lieu of being able to go to the farm, meet the farmer, shake hands, and know where your food is coming from. It is vitally important that people take that extra step to support your local economy and to support your local farmer, to support your local ecosystem. And we're lucky in this area to have a glut of really talented, principled stewards and farmers to choose from. So get out there and start shaking hands. And let's see, the last question. Oh, not the last question. Great. Let me take this one here. What are the barriers that prevent farmers from changing from the use of fertilizers and pesticides? That's a great question. The barriers are many, and the barriers are primarily economic collapse. As I said, when we stopped spraying fertilizers and reseeding and tilling and plowing and disking and spraying, we ran out into the field the next spring, being naive as we were, to expect the grass to become back abundantly as it had the year before, and even more abundantly because we had stopped poisoning it. That was our thinking. What we found was a collapse of our ecosystem. We thought we had caused that collapse, and we panicked about it. And what we came to realize later is we had just uncovered the collapse that had been there for 40 years during conventional chemical management, that the field was incapable of producing on its own because the biology was dead. The answer might have been, go back, call the trucks and have them come up and re-fertilize. And were we put to an economic cliff, we might have done that, and many farmers do that because they're stuck. They can't afford to lose crops for a few years and keep the land in the family. So we were fortunate. We had a horse boarding business here that was, still earning, and it allowed us to lose hay crop for years, but most farms can't do that. And so it's that getting across that economic collapse that is the biggest hurdle. RFN hopes to help farmers with that, and there are great companies out there developing ways to help farmers across that precipice through carbon credits, buying up carbon credits, bridge loans, all this sort of thing. So I'm very encouraged that the industry is waking up to that problem and finding ways to solve it. But also there's a cultural element to it where, this is what I do. This is what my father did. This is what my grandfather did. This is what I learned at ag school. It works, and you're not going to tell me different. But that's more anecdotal. I've never honestly run into a farmer where that's the answer. Farmers, in my experience, want to create abundant, productive landscapes for themselves and their kids. And if there's a way to do it while keeping the lights on and making a living, they're going to do it. They're going to consider it. Great. So how can we spread the word about benefits of regen ag and increase more farmers and gardeners to use the system? Great question. Oh gosh. Well, the first is to buy every book you can. I recommend Jeff Lowenfeld's. He does some great books on teaming with microbes, teaming with nutrients. I love the books of hometown hero Judy Schwartz, Cow Save the Planet, Water in Plain Sight. Obviously, I'm a fan of Alan Savory's work, Holistic Management, for forget the exact title, Holistic Management by Alan Savory. Grass, Soil, Hope by Courtney White. Buy these books, read these books, pass them out. That's how I really caught the bug, is a friend handed me a book. And I think that's one of the most effective ways to do it. The other is to share, go to YouTube and share. There are great before and after pictures and stories and really emotional pleas for people to get involved and to learn more about it. Go and find those. A great organization is called Kiss the Ground, and the film called Carbon Cowboys is great. Find those, share those with your friend, post them on social media. Just help get the word out there that we do not have to, as a human species, destroy the planet to feed ourselves. There's a way that we can feed ourselves, even the booming population, for centuries, if not millennia to come, while cooling and stewarding the planet. Okay, we're past the hour, but I'll take one more question here, which is, can you provide resources or for lists or members of regenerative farming? Absolutely, I would love to. And there are great directories coming online now and have been in development for years. I think the most efficient way to do that, because I can't rattle off the directories off the top of my head, is to put together a list, and then anybody who had registered here for this webinar, I'll deliver that list to Mike, and he can pass them out with the link to the video recording, if that suits. But always, feel free to email me at this email address, go to our website, call me, text me, I'm around. I never leave the farm, in fact, and that was true before coronavirus. So you can always get a hold of me, and I would love to hear from you. And I thank you all for coming today and for your interest, and enjoy the rest of the Solar Fest.